BC coast is also home to one of the most iconic, recognizable, and lovable aquatic mammals, the sea otter. Sea otters have actually endured a long, dark history in North America.
At first, it looked like nothing could be done. The once vibrant coastal waters of Western Canada had turned eerily silent. The kelp forests, towering underwater jungles that supported thousands of marine species, had vanished. In their place, stretched endless beds of spiny sea urchins, gnawing away at the last scraps of life. Fishermen left with empty nets. Marine biologists feared total collapse. It was as if the sea itself was dying. But then came a wild idea, unconventional, risky, and even controversial. What if a species nearly wiped out by fur traders a century ago could be the one to bring life back? When Canada released hundreds of sea otters into those lifeless waters, no one imagined what would happen next. When kelp forests disappeared. Along the coast of British Columbia, the ocean used to be full of life. Beneath the surface, large forests of kelp stretched for miles. These underwater plants created a healthy and balanced environment where many species could live. Fish, crabs, shellfish, and even birds depended on these kelp forests for food and shelter. For generations, the coastline supported fishing, tourism, and local communities. But over time, everything began to change. By the middle of the 1900s, scientists and fishermen started noticing something strange. The kelp forests were disappearing. In their place, the seafloor was being taken over by sea urchins. These small creatures may seem harmless, but they feed directly on kelp. Without anything to stop them, they began eating the kelp down to its roots. The once green ocean floor turned into an empty, rocky space, filled with thousands of sea urchins. These areas became known as urchin barrens, because almost nothing else could survive there. The reason the urchin population exploded was because their main predator, the sea otter, had almost completely disappeared. During the 1700s and 1800s, sea otters were hunted for their fur. They were killed in large numbers, especially along the west coast of North America. By the time hunting was finally stopped, very few otters were left. With no natural predators, sea urchins began multiplying quickly. This created an imbalance that destroyed much of the ecosystem. The impact was severe. Without kelp, fish populations dropped. Young salmon, which needed kelp to grow and hide from predators, became more vulnerable. Coastal communities that depended on healthy marine life began to suffer. Some fisheries collapsed, and traditional food sources became harder to find. Even the shoreline became more unstable because kelp had helped to protect it from waves and erosion. Researchers started to worry that the damage was beyond repair. Decades of change had weakened the natural balance of the coast. The disappearance of sea otters had caused a chain reaction that damaged everything else. The ocean was still there, but its life was fading. It no longer supported the same fish, birds, and underwater plants. What was once a rich and colorful ecosystem had become silent and empty. The situation was becoming urgent. Scientists and conservationists knew something had to be done. If the sea was to recover, the first step was to find a way to bring balance back to the system. Many ideas were discussed, but one stood out above the rest. It involved bringing sea otters back to the very places where they had once been wiped out. This idea would soon become the center of one of Canada's most important conservation efforts. It was a risky plan, but it offered one last chance to save the dying sea. Operation Otter, Canada's radical reintroduction strategy. In the late 1960s, Canadian scientists and environmental officials developed a bold recovery plan to address the growing collapse of marine ecosystems along the country's Pacific coast. Their strategy focused on a single species, the sea otter. After extensive ecological research, they concluded that bringing this predator back could trigger a chain reaction that might reverse decades of damage. This approach became known as predator-led restoration. At the heart of the plan was a powerful idea. Some species are so important to their ecosystems that their presence or absence shapes everything around them. Sea otters are one of these species. Without them, critical underwater plant life disappears. With them, the balance returns. Canada's goal was not simply to protect an endangered animal, but to use that animal to help heal the environment. The plan was guided by ecological science that predicted a trophic cascade. a domino effect that begins when a top predator controls the population of a species lower in the food chain. In this case, sea otters would reduce the number of sea urchins. Fewer sea urchins would allow kelp forests to grow back. Healthy kelp would then create space for more fish, crabs, and marine life to return. The final goal was the restoration of the entire coastal ecosystem. To give the plan a chance at long-term success, Canada also worked on selecting release zones that could support natural population growth. These areas would need strong kelp beds, limited human activity, and some level of protection from industry. The strategy included monitoring, public education, and the development of protected marine zones over time. This approach was a major shift in conservation thinking. Instead of simply stopping harm, the goal was to actively rebuild what had already been lost. The plan was controversial from the start. It relied on long timelines, uncertain outcomes, and the hope that one animal could trigger wide environmental change. But for those involved, the stakes were worth it. They were not just trying to save an animal. They were trying to bring an entire sea back to life. As planning turned into action, the reaction from coastal communities came quickly. The backlash begins. As soon as news of Canada's sea otter reintroduction plan became public, opposition followed. While scientists viewed the return of sea otters as a hopeful path to restoring a broken ecosystem, many people living along the coast saw something entirely different. For shellfish harvesters, indigenous communities, and commercial fisheries, the sea otter was not a solution. It was a threat. The most immediate criticism came from the shellfish industry. Sea otters feed on sea urchins, clams, mussels, crabs, and other invertebrates that are also valuable to human harvesters. In areas where sea otters had been absent for decades, these species had become key parts of the local economy. Shellfish diving and handpicking provided income for families and small businesses. The return of a hungry predator, especially one with a daily appetite equal to about a quarter of its body weight, raised serious concerns. Many feared that sea otters would quickly deplete shellfish stocks and make it impossible for local harvesters to compete. Critics pointed to examples from Alaska, where the return of sea otters had sharply reduced harvest levels in certain regions. Some called the reintroduction effort reckless, claiming that it favored wildlife over people. Others were angry that the government had moved forward without fully explaining the long-term impacts on coastal livelihoods. Tensions also rose within indigenous communities. In some cases, First Nations groups expressed concern that the decision had been made without proper consultation or collaboration. Sea otters were historically hunted and managed by indigenous peoples for generations before the fur trade devastated their numbers. Now, the sudden return of the animal, managed by government agencies, was seen by some as yet another outside decision affecting traditional territories and marine resources. One early flashpoint was Checlisette Bay, where word of possible otter releases sparked strong community reactions. Fishermen voiced frustration at the lack of clear communication. There were worries that conservation goals would override the realities of daily life for people who depended on shellfish harvesting. For these communities, the arrival of sea otters was not just an environmental change. It was a direct challenge to food security, economic stability, and cultural traditions. In public meetings and coastal towns, emotions ran high. Some people supported the idea of environmental recovery, but questioned why local voices had not been heard sooner. Others simply rejected the plan outright, demanding that the reintroduction be halted. Despite this criticism, the government moved ahead. Officials promised that they would monitor the effects carefully and make adjustments as needed. But bringing sea otters back to the wild would prove far more complicated than anyone expected. Difficulties of release and signs of hope. Turning Canada's plan into reality was not a smooth process. Reintroducing sea otters to the wild required careful handling, detailed coordination, and a great deal of patience. Between 1969 and 1972, roughly 89 sea otters were captured from healthy populations in Alaska and brought to the west coast of Vancouver Island. The project team included scientists, veterinarians, transport crews, and conservation officials. Every step had to be done with care, since sea otters are highly sensitive to stress and unfamiliar environments. The transportation process alone was complex. Otters were moved by boat and military aircraft, housed in specially designed tanks to keep them safe and calm during the journey. Despite the best efforts, not all of them survived the trip. Some became sick or stressed during transit. Others were released into the wild but immediately fled the area. A few returned to shore or vanished altogether. In the early stages, only a fraction of the relocated otters stayed near the release zones. The animals did what they were known to do: consume large amounts of shellfish every day, including sea urchins, crabs, clams, mussels, and sea cucumbers. As expected, this led to noticeable changes in the local marine environment. In the weeks following the release, harvesters reported sudden drops in shellfish availability near the release sites. Sea urchin beds that once covered the ocean floor began to shrink. Crab traps came up emptier than before. In certain coves, divers noticed a decrease in visible mussel and clam populations. What made the situation more complicated was the unpredictability of the otters themselves. They did not settle in neat patterns or remain in confined areas. Some traveled great distances, while others refused to stay in the designated zones. This made it difficult for scientists to monitor the population and assess early progress. The challenges led some critics to declare the project a failure before it had a chance to take root. But quietly, small signs of hope began to emerge. In limited patches where sea otters remained, scientists noticed that sea urchin numbers were starting to decline. In a few locations, the thick purple carpets that once covered the seafloor began to thin. It wasn't yet a recovery, but it was movement in the right direction. By the early 1980s, despite setbacks and ongoing resistance, a small population of sea otters had begun to take hold near Checklisset Bay. Their numbers remained modest, but their presence showed that the concept might work if given time and support. The long-term vision was still far from complete, but the ecological pieces were beginning to shift. First signs of recovery. After years of uncertainty, the first signs of success began to appear in the waters off Vancouver Island. In the areas where sea otters had managed to survive and stay, scientists began noticing clear environmental changes. Sea urchin populations were shrinking, not just in scattered patches, but across wider sections of the seafloor. The thick purple mats that had once smothered the ocean bottom were slowly disappearing. In their place, something extraordinary was happening. Kelp was coming back. Kelp is one of the fastest-growing marine plants in the world. Once the urchins were removed or reduced, the kelp took advantage of the open space and sunlight. Within just a few years, underwater forests began growing again. In places that had been barren for decades, long strands of kelp waved gently in the current. These forests were not just a visual improvement, they were a sign that the ecosystem was rebuilding from the ground up. The return of kelp brought many other changes. Juvenile fish began using the kelp beds for shelter, just as they had in the past. Crabs, sea stars, and small invertebrates returned as well. Some of the kelp beds even began attracting birds and sea lions that relied on the fish living inside them. Divers who had once described the region as lifeless now reported scenes full of color, movement, and variety. The transformation was fast, measurable, and almost unbelievable. What made the recovery more powerful was that it happened without further human interference. The otters had started a natural process. By feeding on urchins, they had cleared the way for kelp. The kelp created food and shelter for dozens of other species. That simple chain reaction, predator eats grazer, plants regrow, life returns, became one of the most compelling success stories in marine conservation. The changes weren't limited to one area. As the otters slowly spread beyond their original release zones, other patches of kelp forest began to recover. In locations where the otters had been consistently present for a few years, the results were nearly the same each time: fewer urchins, more kelp, and a growing population of fish and invertebrates. These patterns gave researchers the confidence that the project was on the right path. By the end of the 1980s, the connection was clear. Wherever sea otters remained for long periods, the ecosystem began to heal. The project had faced criticism, setbacks, and skepticism, but the first real breakthrough had arrived. A living forest had returned to the sea. And as those kelp forests grew taller and stronger, they didn't just support marine life. they began changing the entire environment, triggering a chain reaction that proved the sea otters had done exactly what Canada had hoped: the full ecological chain reaction. Once kelp forests took hold, the surrounding ecosystem began to transform in ways that exceeded even the most optimistic expectations. With kelp forests firmly re-established, the coastline experienced one of the most complete and wide-reaching ecological recoveries ever recorded in Canadian waters. Kelp helped stabilize the ocean floor by reducing erosion caused by waves and currents. In areas where kelp returned, the shoreline became more resilient. This helped protect coastal habitats from damage during storms and high tides. At the same time, kelp played a major role in improving water quality. It absorbed carbon dioxide from the water, helping to reduce acidity and support healthier conditions for marine species. Beneath the canopy of kelp, fish populations expanded rapidly. Rockfish, greenlings, herring, and juvenile salmon found safe refuge within the dense forest. These fish, in turn, attracted larger predators like seals. Shellfish species not targeted by otters, such as certain scallops and smaller crabs, began repopulating the area. Dozens of invertebrates, including brittle stars, anemones, and nudibranchs, reappeared. Seabirds returned to feed on the abundance of marine life. The coast was no longer quiet or barren. It was full of movement, sound, and life. The presence of sea otters also began to shift the behavior of other species. With a dominant predator back in the ecosystem, prey populations adapted to avoid overgrazing. This change helped maintain a more balanced food web. Unlike artificial control methods, the sea otters kept the urchin population under control without wiping it out completely, allowing just enough urchins to remain without damaging the kelp beds again. As the otters moved into new territories, they brought the same results. Local urchin numbers dropped, kelp returned, and biodiversity increased. The impact stretched far beyond the original release zones. Over time, the healthy marine zones expanded outward, creating corridors of restored habitat all along the west coast. By the early 2000s, the sea otter population had grown far beyond its original numbers. In British Columbia alone, the population reached over 3,000 by 2004 and more than 5,600 by 2013. In other parts of the West Coast, including California and Alaska, similar patterns were observed. Sea otters were not just surviving, they were thriving and leading an ecological revival. Scientists began referring to the project as a textbook example of a successful rewilding effort. "It's done," researchers would say, cheering their efforts, in recognition of a full ecological recovery triggered by one bold decision. What had once been written off as a dying coastline had come back to life in full. The transformation was complete. Interestingly, the recovery wasn't just environmental. It also brought unexpected benefits to the economy and the climate as well. Economic and climate benefits. The return of sea otters not only revived British Columbia's marine ecosystem, but also produced a set of economic and climate-related benefits that few had fully predicted at the beginning. As kelp forests spread and marine life rebounded, scientists and economists began to examine the broader impact of the recovery. What they found was a rare example of environmental restoration delivering direct financial value, while also supporting long-term climate goals. In 2020, researchers from the University of British Columbia conducted an in-depth economic assessment of the sea otter reintroduction. Their findings showed that healthy sea otter populations contributed an estimated $53 million per year in combined benefits to the region. These benefits came from three major sources: increased fish productivity, enhanced carbon storage, and a boost in tourism. The resurgence of kelp forests played a key role in improving fish habitat. Many commercially important species, including rockfish and herring, use kelp beds during critical parts of their life cycle. With more shelter and food available, fish populations grew stronger and more stable. This created improved conditions for sustainable fishing practices, especially in areas adjacent to otter zones where balance had been restored. Kelp also serves as a powerful natural tool in the fight against climate change. It absorbs carbon dioxide from seawater and stores it in its tissues as it grows. When kelp dies, some of that carbon sinks to the ocean floor, effectively removing it from the carbon cycle. The expanded kelp coverage resulting from otter activity increased this carbon capture ability. While not a replacement for larger climate strategies, the effect was meaningful and offered a model for how marine ecosystems can contribute to climate resilience. Perhaps most noticeable to local communities was the rise in ecotourism. Sea otters are charismatic animals that attract visitors eager to see them up close in the wild. Whale-watching companies, diving tours, and coastal lodges began offering otter-specific experiences. In several towns along Vancouver Island, small businesses benefited directly from the renewed presence of wildlife. The sight of otters floating in kelp beds or diving for crabs became a valuable part of the tourism economy. It is true that the return of sea otters brought trade-offs. Some shellfish harvesters experienced reduced catches of sea urchins, mussels, and crabs. However, the UBC study confirmed that these losses, estimated at about $7 million per year, were far outweighed by the ecological and economic gains. In the long run, the coastal economy proved more stable and diverse with sea otters present. By 2025, the sea otter population in British Columbia had continued its steady rise, expanding into new regions and helping restore ecosystems across hundreds of kilometers of coastline. This natural recovery had evolved into a broad success story, one that improved livelihoods, protected biodiversity, and supported climate stability. With the otters now fully established and the environment transformed, scientists and policymakers began asking a new question. What comes next for this powerful model of ecological recovery? What comes next? With the recovery firmly in motion, the question now facing scientists and policymakers is how to protect and build upon this success. The return of sea otters has proven the power of ecological restoration, but maintaining that progress will require foresight, cooperation, and adaptation to new challenges. One of the most pressing concerns is the risk posed by marine pollution and oil spills. Sea otters are highly vulnerable to contaminated waters, particularly oil, which destroys the insulating quality of their fur and can lead to rapid hypothermia. The memory of the 1989 Exxon Valdez disaster in Alaska still looms large, where thousands of otters perished. Future conservation efforts will need to include stronger safeguards against industrial accidents, stricter regulations on shipping routes, and emergency response strategies tailored to protect marine mammals. Another challenge lies in balancing conservation with the needs of coastal communities. Some indigenous groups have raised the need for shared management approaches that recognize traditional knowledge and food security concerns. Collaborative stewardship models are emerging, where First Nations work directly with government agencies to monitor otter populations and co-manage marine resources. These partnerships may become essential for building trust and ensuring long-term harmony between ecological goals and cultural traditions. Climate change is also reshaping the conversation. Rising sea temperatures, changing currents, and increased ocean acidity could influence both kelp health and otter distribution. While the current ecosystem is stable, future shifts in the environment may test the resilience of this recovery. Scientists are beginning to study how kelp forests can serve as carbon sinks on a larger scale, and how sea otters can be integrated into broader climate adaptation strategies. Looking forward, Canada's experience may serve as a blueprint for other nations facing ecosystem collapse. The lessons learned from patient planning to community engagement highlight the importance of acting early and restoring natural balance. What began as a local experiment has evolved into a global example of what is possible when nature is given the chance to heal. What do you think about this project? Thank you for watching. See you in the next video.